This lesson is on rational numbers. It is the first lesson in your textbook. Your objective for this lesson is you will learn to write equivalent fractions and decimals. So go ahead and set up your notebook in Cornell note format and title your notes with rational numbers. We're going to start out with some vocabulary. The first vocabulary word you need to record is rational number. A rational number is a number that can be written in the form of A over B, where A is an integer and B is any non-zero integer. So basically, a rational number is a number that can be written as a fraction. And since we cannot divide by 0, we cannot have 0 in the denominator. So B cannot be 0. A rational number can be expressed as a ratio or as a comparison of two numbers. If you remember from last year, a ratio can be expressed as a fraction. So a fraction or a rational number can also be expressed as a ratio. It can be expressed as a fraction, as we just talked about. Any number that can be expressed as a fraction is a rational number. It can be expressed and written as a quotient of two integers. Remember, a quotient is the answer you get when you divide two numbers. Well, a fraction is also a division problem. If I have the fraction 3/4, that can also be read as 3 divided by 4. So the answer to that would be the quotient. So a rational number can be written as a quotient of two integers where the divisor is not 0. And a rational number can be written as a decimal. Decimals are rational numbers if they terminate or repeat a group of digits forever. Okay, so a rational number can be a decimal that terminates or repeats a group of digits forever. Keep that in mind. You need to have these vocabulary words written down with their definitions. We'll continue with some vocabulary words. A terminating decimal is a decimal that stops. For example, 0.375 is a terminating decimal because it terminates or stops. A repeating decimal is when a decimal expansion repeats the same digit or group of digits forever. For example, 4.83333, that 3 continues to repeat. So notice how we write that. We write that as 4.83 with a bar over the 3. Now the bar is only over the 3, not the 8, because only the 3 is repeating. Another example is 0.18181818, and it would continue on, repeating the 1 and the 8. So we would write that as 0.18 with bar over the 1 and the 8, indicating that both of those digits repeat. Now we're going to talk about writing terminating decimals. We have the problem where we're asked to write 36/125ths as a decimal. To do that, we need to divide the numerator by the denominator. So the numerator goes inside. The number on top goes inside. We're going to divide that by the number on the bottom. We have 36 divided by 125. Obviously, 125 cannot go into 36, so we need to add a decimal point and some zeros. Now, if we look at our fraction, 36 over 125, 36/125ths, is smaller than the number 1. So our answer in decimal form should be less than 1, which means it's going to be just the decimal expansion, the numbers past the decimal point. So we have 125 cannot go into 36, but it can go into 360, and it goes into 360 two times. 2 times 125 is 250. We subtract, find the difference, and we get 110. 110. And this is long division. We need to make sure we understand how to divide and do long division. So we'll do some practice on that quite a bit this week. We have a remainder of 110, so we're going to bring down a 0, and 125 doesn't go into 110, but it does go into 1,100, and it'll go into 1,100 8 times. 8 times 125 is 1,000. We subtract, find the difference. We're left with a remainder of 100. 125 will not go into 100, but it will go into 1,000, so we bring the 0 down. And 125 goes into 1,000 8 times. We found that out on our last calculation. We multiply that. 1,000 minus 1,000 is 0. We have a remainder of 0. So whenever we have a remainder of 0, that means we have a terminating decimal. Our terminating decimal is 0.28 or 0.288. We understand that if there's nothing in the ones place, we can write it as 0.288. The 0 is really just a placeholder. So these two numbers, 0.288 and 0.288, are equivalent. They both represent the same value. The next slide will give you an example of the study card for this concept. Now we're going to look at writing repeating decimals. We are being asked to write 27/99 as a decimal. Now notice 27/99 is less than 1. So we need to set up our division problem so that we get a decimal that is less than 1. 27, the numerator, goes inside. The 99 is on the outside, knocking at the door. If I were to set it up incorrectly, I would have 27 going in 99, and that 27 does go into 99, so that would be a number greater than 1, and that should be a red flag that I've set up my problem incorrectly, because as we said above, the 27/99 is less than 1. Now 99 does not go into 27, so I need to extend my bar and add some zeros. So I'll put a decimal point there, add some zeros. 99 does not go into 27, but it does go into 270, so I'll carry my decimal point up, and 99 goes into 272 times. 2 times 99 is 198. When I subtract, I get 72, a remainder of 72. 99 does not go into 72, so I need to bring down a 0. And then 99 into 720. It does go into 720 7 times. 7 times 99 equals 693. When I subtract, I get a remainder of 27. Now notice we were originally dividing 99 into 27, so we're back to our original problem again. 99 cannot go into 27, but it can go into 270, so I'm going to bring down a 0. 99 goes into 270 2 times. We saw that once already. 2 times 99 is 198. When I subtract, I get a remainder of 72. We've had a remainder of 70 once already, so we know 99 will not go into 72, but it will go into 720. So we bring down another 0. 99 goes into 720 7 times. It's the same as we found earlier in this problem. 7 times 99 is 693. I subtract, I get a remainder of 27 again. You should see a pattern here. We're either getting a remainder of 72 or a remainder of 27, and those remainders keep repeating. So that means we have a repeating decimal in our answer. And our repeating decimal is either 0.27 repeating with the bar over the 2 and the 7, because those are the digits that do repeat, or we can also write that as 0.27 repeating with the bar over the 2 and the 7. Again, it's important to put the bar over both the 2 and the 7 to indicate that those are the digits that repeat. Now we're going to look at equivalent fractions. we're being asked to write 1.345 as a mixed number in simplest form. Okay? One way to do this is to understand that 1.345 can be written as 1.345 over 1. Because any number over 1 is equivalent to itself. It's equal to itself. So I rewrote it that way. And I'm just going to drop down a line, and I still have 1.345 over 1. And I'm going to multiply that times 1,000. And the reason I chose 1,000 is because I have 3 digits past the decimal point. I need to move that decimal point to the 1, 2, 3 times in order to get a whole number. And to do that, I need to multiply by 1,000. Notice the 1,000 has 3 zeros in it, and I want to move the decimal point 3 decimal places. So that should help you determine what you need to multiply by when we want to change a decimal to a whole number. You should have the same number of zeros in the number you're multiplying by as you do digits past the decimal. Okay, so 1.345 over 1 times 1,000 over 1,000. Now any number divided by itself is equal to 1. So 1,000 divided by 1,000 is equal to 1. So I'm multiplying this number times 1, in essence, is basically what I'm doing. So I'm not changing its value, I'm just changing the way it's written. Okay, so I'm changing the way it's written, but not the value of the number. When I do that, I get 1,345 over 1,000. Now if I was actually to divide that back through, I would get 1.345. So they are equivalent. 1,345 over 1,000 is equal to 1.345. It's just another way to write the same value. I want to write it this way so that I can change it to a mixed number. I finally have a fraction. I just put my decimal into fraction form, and now I need to write it as a mixed number. Well, we know 1,000 can go into 1,345 one time, so my mixed number is going to be 1 and something else. But before I figure that out, it would be easier to reduce this fraction. Then I can work with a smaller fraction. I noticed that the numerator ends in a 5, the denominator ends in a 0. That means both the numerator and the denominator are divisible by 5. So I'm going to divide the top and the bottom both by 5. So whatever I do to the top, I have to do to the bottom. When I divide both of those by 5, I end up with a reduced fraction of 269 over 200. Now this is much easier to see the fractional part of the mixed number. 200 will go into 269 one time, and I have a remainder of 69. That's 69 200ths. So our mixed number is 1 and 69 200ths.